So today we will be starting with some basics of visualizations, basics of plottings, how to draw plots in Python. So the main libraries that we will be focusing will be matplotlib and seaborn. Visualizations, libraries. Most used library or most basic library is your matplotlib. All the other visualizations library, whether it is seaborn or your plotly or cufflinks, all these are written above matplotlib functions itself, right? And the other one is seaborn, basically used for plotting statistical plots, statistical figures of your data. So we'll be starting with the matplotlib itself. First of all, we will be importing all the libraries that we are going to use, right? So we'll import NumPy, Pandas, Matplotlib, and Seaborn itself. From Matplotlib, PyPlot is imported as PLT. In PyPlot module, there are functions that we generally use for plotting, right? Now, before moving on to forward, let's create some synthetic data on which we will be creating our plots. So first of all, let's create a data of water saturation by using NumPy's function of linear linspace. If you remember np.linspace, that is generally used for creating your arrays starting from a number going to a number and giving total number of data points that we want. So I'm creating an array having values from 0 to 1 and having 100 data points and storing that inside the variable SW. If you see your SW, look like this particular thingy, right? Now, I'm going to calculate the water relative permeability of water and oil by using the correlations, some of the correlations that you can find out in the reservoir engineering book, just like Tariq Ahmed or LP Dake, right? So I'm using one of the correlation for calculating my relative permeability of water with with respect to by using the value of saturation of water. So the particular correlation for this particular thing is KRW is equal to saturation of water to the power 3. I don't remember exactly the name of this particular correlation, but yeah, you will be able to find all these different correlations in some of the general reservoir engineering book, right? So KRW array for this KRW has been generated by just taking the cube of my SW, right? Now let's also find out the relative permeability of oil, right? Let me write it KRW here that it is yeah, yeah, it's the relative permeability of water and ARO is relative permeability of oil, right? So my KRO for this particular correlation will be calculated by 1 minus SW to the power 2, complete to the power 2. So in this way, one array for KRO is generated, one array for KRW is generated. Now we will be plotting our relative permeability plots that we generally see in the textbooks or in some softwares also. So before moving on to that, let's put all this data in one particular data frame itself, right? So that the complete data is in will be in a tabular form with us, and we can also save that particular data inside your local system as a CSV or Excel file, right? So we have already imported our pandas, right? So I'm going to use my pandas data frame function for creating the data frame out of these arrays. Inside it, I'm just passing a dictionary. If you remember, the keys will be your columns, right? And the column names and the data it will automatically take from the array itself, right? So for my SW, or let's say water saturation column name, my data will be the variable SW, right? So at rel pump of water, this will be your KRW. Rel pump oil will be your KRO. K is small. I have to change them. So if you see this particular data frame, your complete data has been changed into a data frame itself. Now, if you notice and think think technically, you can see when your water saturation is increasing, your relative permeability of water will increase, right? So you can see when my SW value was 0, my relative permeability of water was 0, and my relative permeability of oil is 1, right? So as the water saturation will increase, your relative permeability of water will increase, and your relative permeability of oil will decrease, right? So it will start from 1 and go to 0 at the point when my water saturation reaches 1. Right? Now, what you can directly do, if you remember it from the last class itself, in the data frame also, there is this plotting function itself inside your data frame variable, right? By just using df.plot, and if you hit this particular cell, you will be able to see the complete plots has been shown for the complete data. So this data frame was having 3 columns: water saturation, rel pump of water, and rel pump of oil. So these 3 lines are present inside this complete figure itself here, right? Now, and by using subplots is equal to true, you will be able to plot each of the column differently in one figure itself, right? These are all these things are from the previous classes itself or previous sessions itself. So in this way, you will be able to see your relative permeability of water differently and your relative permeability of oil differently. Now, what if you want to plot these two particular, your oil and water curve itself only? So in that scenario, what you can do, you can slice your data frame, right? By using just the name of these 2 columns. One, one way is that, but now we are going to use our matplotlib library, and we will see how the line plots or scatter plots, different type of plots be made by using this particular matplotlib. So this plotting thing will be your step by step guide, right? So we will be starting with our first step. Our first step is plotting KRW, or you can say plotting relative permeability of water with respect to your saturation, right? So on the x-axis there will be water saturation values. On the y-axis there will be relative permeability of water values. So step 1, KRW versus SW plot, right? Now for plotting this, for drawing a line plot, you can just use plt.plot function present in matplotlib library, and inside it just pass the value that you want to be put on your x-axis and y-axis. So on x-axis I want my SW, so I will be writing SW first, and on the y-axis I want my KRW, so I will be writing KRW after my SW, right? So a simple looking plot has been generated here. On the x-axis, your relative permeability, your not relative permeability, your water saturation values will be there, and on the y-axis, your relative permeability of water values will be there. Our first step is done, right? Now my second step will be step 2, will be doing the same thing for my relative permeability of oil. So drawing a KRO versus SW plot, right? So what I will do, I will do plt.plot SW and KRO. So this is my relative permeability of oil plot, right? Now I want these both plots, KRW and KRO, on the same figure itself, right? So my step 3, next step will be plotting KRW and KRO on same plot itself, so that it will share the same x-axis of your water saturation, right? So step 3, KRW and KRO versus SW plot, right? So what you need to do, you just write a simple plt.plot. Okay. just pass your SW versus KRW, right? So it will generate your SW versus KRW plot. And in the next line, just write the other plot that you want to show within the same figure. So I want to show the plot of SW versus KRO, right? So just putting these two both lines together is going to put both the line plots in one figure itself. Now you can see the blue one is your SW versus KRW, and the orange one is your SW versus KRO. Both the relative permeability values are plotted on the same plot, right? With the common x-axis of your water saturation. Now I want to give the labels on the x-axis and y-axis so that someone who is seeing this particular plot will know that okay, what does these x values representing, or what does this y values representing, right? I'm plotting which two variables together, right? So my step 4 will be giving the name of labels, giving the axis labels name, right? So our first two line of code will remain same, plt.plot of SW, KRW and KRO. And after that, for putting the name of your X label, you can use plt.xLabel function of your matplotlib. Inside it, just pass the string of the name that you want to give to your x-axis. So for example, on x-axis, our water saturation is present, right? So I will write water saturation, and these are fraction values, right? So let's pass fraction also, right? Similarly, for my y-axis, plt.y label, on my y-axis, what values are there? Relative permeabilities are there, right? So I will just pass relative permeabilities. So here you go. Now, if you see the plot on the x-axis and y-axis labels are present, right? So we have plotted a simple line plots with the labels present there, right? Now my next step will be adding the grid lines also, right? So that some graph type of structure it will become. By using grid lines, you will be able to know that, okay, on a one particular value on 0.2, what exact value of KRW is present, right? By just following the grid line, straight line thingy, that thing. So for plotting the grid lines, or for representing your graph like of structure, the next step 5 will be grid. Again, the first four lines will remain same. And after that, there is this grid function inside matplotlib, plt.grid. Just pass true boolean inside it that, okay, I want my grid lines to be present in the figure. Here you go. Now you can see these particular grid lines appeared, and your this plot is kind of looking like a graph paper, right? So you can just see by following this particular grid line, what will be the value of your KRW at when your SW is 0.4. So we are kind of beautifying our plots. Started with the basic one line plot, right, of KRW versus SW. Then we plotted to two lines on the same figure itself. We have added the labels of X and Y axis, and we have also added the grid lines. Now, our next step will be the providing the legends to this plot, right? So that what does this particular thing mean? If someone sees this particular plot, he will know that, okay, orange line is which one? Orange line is value of KRW or KRO, or blue line is value of KRW or KRO, right? So this particular legend thing, or telling that, okay, blue plot is your KRO plot and orange one is your KRW plot, that need to be present there, that information, right? So that particular thing is known as your adding legend to the plot. So steps 6, adding legend to the plot. So our initial steps till here will remain same. I'm just copy pasting them. And after that, we want to add legend, right? So for adding the legend, first of all, we need to provide the labels of these line plots, right? That, okay, this X this PLT dot plot of SW versus KRW. What is the exact label of this particular plot, right? So there is this label attribute present inside your plot function. Inside it, you can just pass that, okay, label, I want to give this particular plot as water rel pump. This is water rel pump plot, right? So label I have provided water rel pump KRW, right? In a similar way, we need to provide the label of your SW versus KRO plot. So there, just pass your oil rel pump, right? KRO. So this particular thing is there. Let's hit this run. We see we are not able to see any particular information of these plots yet, right? So for seeing the information, for showing the information in the plots itself, there is this function plt.legend that you need to write so that legends of these plots will be shown on the figure. So here you can see after just writing this plt.legend, this particular legend has appeared that, okay, your blue plot is your water relative permeability plot and your orange plot is your oil relative permeability plot, right? And inside it, you can again change the location of this particular legend also. For example, it is present here midway. By default, it will kind of show the legends at the best location possible, right? But you can also change these particular locations itself. Just pass this variable location inside your legend. For example, bottom right. Let's see if bottom right is correct. Otherwise, it will throw an error. Okay, it throw an error. So these are the valid location points that you can give. Lower instead of bottom right, this will be your lower right. Right. So here you can see your legend has came to lower right. In a similar way, you can also pass lower left, lower center. Here it is. In the similar way, upper thing you can do upper center. But by default, if you are not providing any location, it will give you the best location possible. So that minimum point or minimum plot area will be going to be under this particular legend, right? And there is this best location also, best. So it will, you can see this particular thing is here. So step 6, legends has been added, right? So we started with a very basic plot that looked like this. Now we are at this particular stage, right? Now after adding the legend, our next thing will be the changing the size of plot, right? For example, this is kind of a little bit small plot currently. I want to change the dimension of this figure, right? I want to make it by my own choice. So step 7. The size of plot. For changing the size of plot, let's first of all copy all this particular thingy there, right? So this is my plot. I want to change this particular size of this particular figure, right? So before starting to write your plotting functions, just write plt.figure. That will set the attributes for your this particular figure, and inside this particular figure, just pass your fixed size parameters. That is kind of figure size, right? And here you can just pass whatever figure size you want your figure to be. So for example, I want 16 cross 20 or 16 cross 10 figure size. So 16 will decide your length, this particular thingy, x-axis thingy, that what will be the length of your figure, and 10, the second one, will decide what will be your width of the figure, right? So here you can see 16 cross 10 will look like this particular thing. Length is 16 and width is 10. So 16 cross 10 is kind of a little bit large, right? Because the complete figure is not coming on the screen itself. So let's change it to 12 cross 8. And instead of 8, let's change it to 6 itself. So here you go. This is your figure. We change the size, right? So in this way, you can provide whatever size you want for your particular figure. Now, our next thing will be, all things are present there, right? By default, it is taking this oil relative permeability curve as orange and this particular thing as blue. Now, if I want to change the colors of these particular lines, So matplotlib also provides that functionality also, that if you want to change the color or kind of want to more beautify your plots, or there are some standards fixed inside your company or for your particular project, that okay, water relative permeability needs to be present in green color, or oil relative permeability need to be present in blue color. So that particular thing you can also do. So my step 8, right? Step 8 will be change the line color. So first of all things again, I'm going to copy paste from here itself. Now for changing the line color, for example, this SW versus KRW, I want this particular line to be dark blue in color. So I will just pass this color parameter, and inside it will pass the value of color parameter as dark blue, right? So here you can see this has been changed to dark blue, right? Your water relative permeability curve has been changed to dark blue, and by default it has taken oil relative permeability as light blue, right? Now instead of this light blue thingy, let's say my color of relative permeability of oil need to be brown in color. So here you go. Your plot is now showing that okay, this particular thing has been changed to dark blue, and your oil relative permeability line plot is changed to brown color, right? So in this way you can change your line colors also. Now there is also functionality for changing the line thickness itself. Line colors we have changed, but there can be a scenario that okay, I want my oil relative permeability line need to be little bit thicker than my water relative permeability line. So you can also change the thickness of these particular lines also. So my step 9, changing the line thickness. So again, all things will remain same. Let's just copy paste here. And inside your plt.plot function, there is this another parameter named as LW, that can you can say line width LW, and inside this LW value, you can pass certain values that okay, I want this water relative permeability line to be little bit less thicker. By default value is 1, so I'm going to pass 0.5, and I want this particular KRO little bit more thicker, right? So let's pass this value as 2. So here you can see this particular line, thickness of this line has been reduced, and thickness of this particular line has been increased. You can also further reduce to this particular, to any more values. Let's increase to 4, and here you can see, right? Now this particular line is kind of less visible. So there is again one more parameter, alpha. Okay, it hasn't taken. Okay, sorry. By alpha also, what you can do, you can kind of change the brightness of that particular line. Now that particular thing is not visible at all because I have set alpha as 0.2. So instead of alpha of water relative permeability, let's set this alpha here. You can see the intensity of the light we have reduced of this particular line, right, by using alpha parameter. So this is also one of the parameter present, right, in our plotting. Now find some of the final steps that we need to do, right, for plotting, for beautifying our plot. We haven't added a title to this plot yet, right? So for example, these are relative permeability plots. I want to add that particular title here somewhere, right? So that other person will know by seeing the plot that okay, this is the relative permeability plot, right? So that thing is also possible. Step 10, title. Let's take these particular values, decrease these points, and line width, let's increase this particular thing to 2. It look like this, right? Great. Now what you can do, you can add the title here below this version 1 plt.title, that okay, title of this particular figure is relative permeability plots or plot, right? So here you go. Your title has been added here. So in this way, we started with the very basic thing, right? We started with the very basic line plot, and our final plot is kind of ready. In this way, you can make your plots. Now, also in your line plots, also you can change the style of plotting itself. What that particular thing mean? Changing the line styling. For example, let's just take this particular code here. For example, I want my these instead of this thick lines, or you can say continuous line, I want my dash lines here, right? Dash lines here, right? So what I can do, after just writing your x values and y values, you can just pass one more thingy, that which type of lines do we want. So if I pass by taking this particular parameter, and if I pass dashed points, minus minus, right? So here you can see dashed line has been produced, right, for your water relativity curve. In a similar way, if I pass plus plus, let's see if it will make some plots or not. No, it has thrown error. So there is nothing, this plus plus point present, right? But instead of 2 plus, if I just use 1 plus, here you can see instead of the complete line plot, the scatters in term of your cross sign has been appeared. So in this way also you can customize or beautify your plot, right? So started from a basic thing. Now our this particular beautiful plot is made. Now what else you can do? You can also change the style of this particular plot, right? So there are some of the styles present in the matplotlib library itself. So if you just pass plt.style.available, you will be able to see different styles. By default it is your normal style, but there are these Seaborn, from the Seaborn library, plotting style is also present. Your classic style is also present. So if I show this particular classic style, how to implement this classic style, final step, our final step, complete beautification, right? So let's first of all copy all this code. And before starting to plot your figure, what you can do below this particular thing here, you can just use plt.style.use and just pass the name of the style that you want to use for from this list, choice of list, right? So here I'm using classic style. Right now you can see this particular plot in the classic style itself. Many of the, if you have worked on some of the oil and gas simulations, some of the old simulation softwares, they kind of use this particular styling plots itself. That's why the name is classic itself. You can see classical days thing, right? So in this way you can also change the style of your plots. So yeah, this was the basic introduction of plotting thing and how you can beautify the plots. In the next session, we will be discussing different types of more plots that are present by using Matplotlib and Seaborn itself. So we will be using certain data set and we'll be doing plotting on that particular thing. Okay, till then, happy learning. Bye bye. Take care.